So now we have our first triad exercise of graphing a hyperbola. And now notice the difference or differences between, and we'll go over other differences as well, but the difference in the equations of an ellipse and a hyperbola in standard form. With a hyperbola, we have this minus between the x squared and y squared terms instead of a plus. Whichever term comes first, whether it's x squared or y squared, determines which direction the parabola opens up. If the x squared term comes first, then it opens left to right, left and right. If the y squared term comes first, then we know it opens up and down. In this case, we know that x squared comes first, so it's going to open left to right. Now, how do we figure out how to graph this? We're going to find points based on, we're looking at this form.
X squared over a squared minus y squared over b squared equals 1.
And when we have this, we can determine points from the center in order to form this box that makes up the corners of our asymptotes and the vertices of the hyperbola. So notice again, with a hyperbola, it matters which term comes first, unlike with an ellipse, because there's a plus in the equation with ellipse. But with a hyperbola, it's minus, and therefore which term comes first determines which direction it opens. So we know, first off, x squared, the x squared term is positive, which means that the parabola opens up left to right. So how do we find let's find our vertices first. So a squared in this case equals 16, which means that a equals 4, or plus or minus 4 if we want to look at it as we're adding 4 and subtracting 4, adding a and subtracting a from the center. So notice that similar to an ellipse, with no terms being added or subtracted to x or y before they're squared, that means that the center is just the origin. So our vertices in the x direction, because that's where a squared is, the x squared term comes first, are going to be at negative 4, 0, and 4, 0. Now, what do we need to do? Well, let's go ahead, and we know that b squared equals 4. So we know b equals plus or minus 2. Now that's the direction, not where the hyperbola itself is going to be, but it makes this box that's going to determine where our asymptotes are. So we're going to go to form our box at 0, negative 2, and 2, 0. And then we can make this box that goes through our vertices and then the points on the y-axis. And our asymptotes, which is what we're going to find next, are what pass through the corners of this box. So we're going to find the asymptotes, though. That box is just kind of a guide, or you could look at it as we're finding the equations for the asymptotes to check our box. So the asymptotes are going to be y equals plus or minus b over a x. So that equals plus or minus 2 over 4 x, which is 1/2 x. So let's see, is that what our box forms? We've got 1, 2, 3, 4 over and 2 up. So a rise over run of 2 over 4 or 1/2. And it goes to the origin. So yeah, that checks out. So we can go ahead and we can draw our asymptotes in. And notice they go through, and this one would be y equals negative 1/2 x. They also go through the corners of our box. So there are our asymptotes. And the hyperbola we know goes left to right, which means those first 2 points were our vertices. Our vertices were, we actually have the vertex of the hyperbola. And then we know it opens left and right, and it approaches these asymptotes
infinitely in those directions.
So to graph our hyperbola, whichever term comes first, determines which direction it opens. If the x squared term comes first, then it opens left and right. If the y squared term comes first, then it opens up and down. And then we found our vertices, which we find a, again, with the form x squared over a squared minus y squared over b squared equals 1. We find a, and then we go that direction left and right from the center. Those are our vertices. And then we find b by taking the square root of b squared as well. And those points are the points on what would be considered possibly a minor axis, if you wanted to call it that. And then we make the box through those points, the rectangle through those points, and the asymptotes go through the corners of that box. We verified that our box was correct by using the formula, the asymptotes when the x squared term comes first. The formula or the equation for the asymptotes is y equals plus or minus b over ax. And in this case, that was plus or minus 1/2 x. And that does verify our box is correct because those lines pass through those corners. And then it opens left and right, so we graphed the hyperbola left and right from the vertices that we found by finding a.